Hello guys, so welcome back to our discussion in organic chemistry, specifically our discussions on alkene and dienes. This is the part 2 of the discussion regarding alkenes and dienes, wherein we will be talking about addition reactions of alkene. So by addition reactions of alkene, it is the most characteristic or reaction or most probable reactions that happens with alkene. Again, we are going back to the notion or the discussion we had on the last video we're in. Due to the presence of pi bond in alkenes or pi bond that is present on our double bonds. These pi bonds are actually, as we said earlier, it can be easily pushed that causes the slight dipole moment of alkenes, and at the same time this pi bond can be easily be broken upon addition of what we call free radicals or electrophiles. So when the pi bond is broken, there will be sigma bonds that will be formed with new atoms. And as you may have remembered, sigma bonds are actually the overlapping or the overlap between the uh, orbitals where valence electrons are present around any atoms. So in that, most of the reactions that are involved in alkenes are what we call addition reactions. So we will be dividing this video into four parts wherein we will be talking about the hydrogenation reaction, electrophilic addition. We will be also looking into uh, oxidation and oxidative cleavage or what we call ozonolysis. We may also add some radical reactions, so it will be five. And the last part of the discussion will be discussing addition reactions of dienes. So basically, that's six parts. So for the first part of the or first parts of our discussion regarding addition reactions of alkenes, let's just mention or enumerate some of the reactions of alkenes. So by reactions of alkenes, we have hydrogenation, electrophilic addition, wherein for electrophilic addition we have five addition reactions, wherein we have addition of hydrogen halide, hydration, which is just basically addition of water, uh, addition of cold concentrated sulfuric acid, addition of halogens, addition of halohydrin, of HOX, or what we call halohydrin formation. We also have oxidation, which is, as you may have remembered, oxidation is just the addition of oxygen atoms to our molecule. Then we have here free radical addition involving addition of HBr in presence of peroxide. Peroxide is it depends on the type of peroxide. And also we have the free radical polymerization of alkenes. So basically, that's all of the addition reaction that we will be talking for alkenes. We have a separate discussions regarding the reactions that happens with dienes, which will be later be discussing in this video. So for our hydrogenation reaction, hydrogenation reaction is simply just adding, or we will be just adding our hydrogen atoms. So in that, having that hydrogen gas, if we have here our double bond between our two carbons, having any R group or hydrogen that is present or bonded uh, to this double bond, and we add uh, hydrogen in the presence of nickel or palladium or maybe platinum, we will actually have here the breaking of the double bond or one of the bonds in the double bond, thus making this compound wherein our hydrogens will be added to this compound. Plus, we have here an additional byproduct which is heat. So as you can see here, we will have here a syn addition of our hydrogen, or by our isomer, we will have here a cis formation. But since this is not a double bond, we will have here the cis addition. It's more of the syn addition. Since we will be adding the hydrogen on each carbon atoms and they will be orienting themselves the same way. So basically, what's special with when it comes to hydrogenation is the production of this heat. So what do we call this heat? This heat is actually what we call the heat of hydrogenation. By heat of hydrogenation, what's so important with this heat of uh, hydrogenation? This quantity of heat is actually evolved when 1 mole of alkene is hydrogenated. So meaning to say, it is actually equal to the enthalpy of the reaction. And as you may have remembered, enthalpy is just our way of uh, uh, saying that the reaction actually occurred, and that amount of enthalpy is equivalent to the amount of the or that change in energy is actually equated to the change in the potential energy of our reactant or our substrate towards becoming the product. And in that, heat of hydrogenation actually gives a valuable information or an important information relative to the stabilities of our alkenes. By stabilities of alkenes, we can ask, knowing that you have an alkene and you want to test uh, the stability of that alkene, you can actually perform what we call hydrogenation. And in that, given the enthalpy or the heat of hydrogenation that you have measured in this reaction, you can actually check for the stability of our alkene. And basically, when we talk about stability, we actually have what we call here the order of stability of our group, wherein the least stable R group will be our metal group, okay? And that will be followed by our primary carbons, secondary carbons, and tertiary carbons. But basically, when we talk about alkenes, uh, what we can have is tertiary carbon. By tertiary carbon, we can have three bonds or three carbon to carbon bonds. And at some point, pwede rin tayo magkaroon ng quaternary wherein we have four bonds or four carbon to carbon bonds. So in that, that is the significance of our hydrogenation. So it is a simple catalyzed reaction. By catalyzed reaction, as you can see here, we have here our catalyst. And bakit natin siya nasabing catalyst? They just hasten, pinabilis lang nila yung reaction natin or yung tinatawag nating hydrogenation. But they don't actually bond to the substrate and to the reagent, uh, wherein you will not see any nickel, palladium, or platinum here in our product side. Okay, all we have here is our original substrate and the hydrogens. Okay, that's our first addition reaction, which is the hydrogenation. So our next five addition reaction is actually characterized under what we call electrophilic addition. And by electrophilic addition, as you may have remembered, this uh, electrophilic molecules are what we call molecules that want to gain electron. So in that, it can be a halide, or no, it can be a hydrogen, it can be our this yung mga bases natin, ayan. So yun yung nangyayari when it comes to our electrophilic addition. Bases o acids? Acids. So in here, actually, we have a certain rule that we must follow in terms of electrophilic addition. By rule, as you may have remembered, we may have some alkenes that are not symmetrical about the what we call here the double bond. So one example here is our propene. So if we have propene, we have a double bond here and a single bond here or a carbon wherein this terminal carbon actually have hydrogen in them and this one has hydrogen in them and we have here our CH3. So this is unsymmetrical about our double bond. As you may see here, we don't have, if we uh, create here what we call a plane or a plane of symmetry when it comes to this, the left side does not looks like the right side. So what we this is what we consider unsymmetrical alkene. So in that, we actually have what we call here a Markovnikov's rule, just in case that we need to add also unsymmetrical reagents. By unsymmetrical reagents, the reagent can have a nucleophile and electrophile. So in that, we need to check kung saan ba mag-a-attach yung ating hydrogens or yung ating mga electrophile. So in that, Markovnikov's rule states that in addition of electrophile to an unsymmetrical alkene, the electrophile attaches itself to the carbon of the double bond that already holds the larger or greater number of hydrogens. For example, if I add here HCl, as you can see here, we have here two atoms here wherein H here can be a positive, can have a charge of positive, and chlorine has a charge of negative. So we have here our electrophile, or H. If we add this to our propene, our hydrogen will actually attach itself to this carbon. Okay? Since this carbon has a greater number of hydrogen than this one, because as you may see here, we have here two hydrogens, and we only have here one hydrogen here. So that is our Markovnikov's rule. Okay? And also, this chlorine will attach itself to the carbon with less number of hydrogens. Okay? So, why do I need to mention this Markovnikov's rule? Because most of our reagents here in addition reaction of alkenes have this hydrogen as our electrophile and some other nucleophile like chlorine, bromine, our sulfates, our hydroxides, and kung ano. But in any case, we have here an electrophilic reaction, addition reaction involving alkenes. So the first electrophilic addition will be the addition of what we call hydrogen halide. So by hydrogen halide, if we have here our double bond here, and this basic formula or basic structure of our alkene, we will actually have here our hydrogen halide, where H is the hydrogen, X is the halide. Also, by halide, hydrogen halide, it can be HCl, it can be HBr, also it can be HI. So, in which we will have here this product wherein we will be breaking the pi bond between those two carbons, and we will have here our hydrogen and our uh, halide. So from alkene, if we added hydrogen halide, we will actually uh, form, or we will have a product which is alkyl halide, okay, which is another functional group in organic chemistry. So for a specific example, utilizing what we call our Markovnikov's rule, say we have here our one, I no, not one. Let's have our two methyl, two, uh, no, that should be two methyl profene. So having this that through two methyl profene, that will be this. We have here this double bond and propene. So we will have here our CH3 and another CH3 here. Okay. Then we will have here our hydrogen and hydrogen. So as you can see here, we have here one, two. That's two methyl propene. Okay. And say we add here hydrogen bromide. What will happen here? So basically, we will have here an H plus and our Br minus, wherein our H plus will attack the carbon. So this is actually an electrophilic attack. It will attack the carbon with a higher number of hydrogen. Therefore, we will be having here a carbon, which is which has the charge that will be attacked by this bromine. So we will have here our CH3, CH3, then we will have there our bromine and our carbon, then our the three of our hydrogen. Okay, so that is how an electrophilic addition involving hydrogen halide will happen. So as your practice, you can actually look into this one. So say we have here our 3 methyl 1 butene. So 3 methyl 1 butene will be 3 methyl 1 butene. What will happen to 3 methyl 1 butene if you add HCl? So basically, same with this example. You just need to consider the Markovnikov's rule. Okay? So for our next example here, or next electrophilic addition, we have hydration, or basically addition of water. So for hydration, this is just basically this is somehow a reversible reaction. By reversible reaction, if we have here our double bond and we added water in presence of an acid, what will happen here is it will actually produce an alcohol, wherein we will have here our OH. But at some scenario, due to the presence or the instability that is introduced by this acid, this reaction is actually reversible. Okay, so at some point, ayun, uh, some of the some of the alcohol actually will reverse back to being an alkene. So that's what happened. So this also follows Markovnikov's regarding the orientation of regarding the orientation on where the hydroxide will attach. So example, say we have here our one methyl na lang ulit. Say we have here one methyl cyclohexene. Uh, hexene. So as you can see here, we have here in. So meaning to say we have a double bond. We have here a cyclo, meaning it is cyclic. Hex, that's six. We have a metal substituent. So what will happen here is this one. So we have here, okay. Then we will have here a double bond and also our metal group, which is the CH3. So in here, if we add water and our reaction have presence of acid, so what will actually happen here is that we will have here water, which is actually H3O3, O3, H3O plus, and we will have here our OH, okay, which is negative. So this H3O plus is actually just a special way of naming or representing our hydrogen. So in here, what will happen is that hydrogen will attack the carbon, which has a greater number of hydrogen. And as you can see here, based on this example, we have for this carbon, we actually have one, two, three, four bonds, meaning it has no. We have here zero hydrogen, and for this one, we actually have one, two, three bonds, meaning to say there's one hydrogen there. So, meaning to say this hydrogen will actually attach itself to this one, this carbon with a double bond, and our OH will attach here on uh, where our hydroxide is actually attached to. So, meaning to say our product will actually look like this. So, wala na yung double bond natin. We will have here our CH3 and we will have here our OH and dito po mag-a-attach natin. So, as you can see, halos pare-parehas yung mga nangyayari. Ano? So, wala namang special. Ang magiging special lang ay laging existent yung ating hydrogen sa mga examples natin. So, basically, same formula or same existence or same reaction pala will happen to the next one, which is actually the addition of cold concentrated sulfuric acid. So typo, pinulang po ako ng acid dyan. That will be sulfuric acid. So our sulfuric acid is actually H2SO4. So as you can see, again, we will have there our H, which is our acid. So what will happen here is same format. So if we have here our alkene and we added our cold concentrated sulfuric acid, cold and concentrated, Why does it has to be concentrated and cold? Kasi yun yung condition na kung paano magpo-proceed yung ating reaction. If the sulfuric acid is not cold and concentrated, this reaction will not proceed. So basically, we will have here same concept. The hydrogen will attach itself to the carbon with or greater number of hydrogen, and our OSO3H will actually attach itself to the carbon with uh, less hydrogen atom, or the carbon that is not attacked by our H plus here. So we will have a product which is not double bond, and we have here our original groups or side groups. And what will happen here is we will have here our H and our OSO3H. Okay? So some of you may be wondering bakit sir naging O3H yung ano natin, yung sulfuric acid natin. Kasi basically class, we are just showing kung ano ba yung itsura ng structure niya. Kasi yung ating H2SO4 is actually the condensed way of writing our sulfuric acid, while our HOSO3 is somehow the better way of representing our sulfuric acid. In that case, using the same example earlier, our 1-methyl cyclohexene, we have our double bond here, our metal group here, and we added our cold and concentrated H2SO4. What happened here is basically same with the hydration, wherein the hydrogen will attach here and the O3H will attach here. So basically we will have this organic compound wherein we don't have the double bond. We have here our metal group, and we have here our OS3H, and we'll have here our hydrogen. Okay, so para hindi malito, let me just add CH3 here and CH3 here. Okay, so for the next one, medyo paspas tayo kasi I hope gigets yun na ng kaunti. Ano? So, let's go to the addition of halogens. Oh, hindi ko natanggal. Anyway, when it comes to addition of halogens, huwag nyo na lang pansinin itong iba. It follows the same concept wherein we have here our double bond, and we just need to add our HX2, wherein we will actually have what we call this one. And we will have here an anti-addition. By anti-addition, uh, the halide will actually be located on either side, or kumbaga hindi sila same ng side na pupuntahan. This is what we call our vicinal dihalide, or what we call 1,2 dihaloalkane. Di because of two, halo because of halogen, alkane because we have here an alkane. So, what actually happens here, kasi baka yung iba nagtataka sa inyo, Sir, uh, I I thought that we are talking about electrophilic addition. So why do we have here a covalent compound? So actually, class, due to the presence of what we call unsaturation, or yung tinatawag natin kakaunti kasi or nabawasan kasi yung number ng hydrogens dun sa alkenes natin, which is yung pinag-usapan natin last time dun sa isa pang video, uh, we we have here a slight dipole moment about the double bonds or our pi bond due to the presence of four electrons in that double bond. So due to the presence of those or the presence of that slight dipole moment, we actually uh, we actually influence the bond in between these two halide. So what happens here is we actually have what we call polarization, wherein two of the electrons here in our halide are actually migrated to one of the halide. So making these two uh, opposite in signs, wherein since we took one of the electrons in the valence shell of this one, we will have here a positive halide. And since two of the electrons migrated to this one, we will have here our X minus. So due to the presence of that X plus and X minus, we consider this as an electrophilic addition due to the presence of this electrophile. So by this electrophile, I mean this halide and this X2 can actually be our Cl2 or chlorine gas and our bromine gas. So actually, class, when we talk about addition of halogens, this addition of halogens actually is an important test for the presence of for the test for what we call unsaturation. By test of unnaturization, such unsaturation, we can actually use our bromine, which is dissolved in carbon tetrachloride. So that carbon tetrachloride, that bromine dissolved in carbon tetrachloride can actually be used for the test of unsaturation. By test of unsaturation, we will be testing if there exists what we call double bonds or single bonds in our organic compounds. So, using bromine in carbon tetrachloride, we can actually check if a substance or a substrate is an alkene or an alkyne. So in that, what happens? So if we have here our cyclohexene, just for example, if we added our bromine and our carbon tetrachloride, we will actually have here our cyclohexane in our PR. And due to that change in the composition of our cyclohexene, there is actually an observable reaction wherein from a colorless liquid, our cyclohexene will actually have a colorization. Like colorization, I can't seem to remember what color is that. But in any case, magbabago yung kulay ng hexene from a transparent na clear na liquid into a colored one. Okay? So, same concept. Still uses what we call Markovnikov's rule, wherein one of the positive halide will attack the carbon with the greater number uh, greater number of hydrogen atoms. and the other one will attack the other carbon with with the original double bond. Okay? So in that, our next reaction is the addition of HOX or the halohydrin formation. So for halohydrin formation, halo, that means halogen, hydrin, that means water. So we will be actually adding our halogen and water. So for our halohydrin, uh, it also follows what we call Markovnikov's rule, and due to the existence or due to the presence of our halide, it also follows the anti-addition, just like our addition of halogens earlier. So in that, if we have our organic alkene or our alkene, and we added halide and water, in which our halide here can be our chlorine or our bromine. So what will happen here is we will actually have a halohydrin, which in we have here our carbon and our this or another carbon, and we will have here our OH and our halide in our side chains. So again, it follows Markovnikov's rule, and also it follows anti-addition. Okay? So sir, paano mo siya magpa-follow sa Markovnikov's rule kung negative at negative din parehas. So anong nangyari dito class, what we are dealing with here is since water have our H plus and our negative OH, and same concept na nangyari kanina, our halide here became one is positive and the other one is negative. So this negative one will actually form a bond with this H plus, and this positive one will act as an electrophile for our alkene. Okay, so one example of our halohydrin formation is we can use our one methyl cyclohexene again. So say we have here our one methyl cyclohexene, okay, and we added bromine, and also we added water. What will happen here is we will have here our HOBr. So we're in our OHBr pala will have this product. Again, we will just remove the double bond. We have here our single bond, and the OH will attach itself to the part where there are no or less number of hydrogen atoms, and also our Br will be attached to the carbon with the higher number of uh, hydrogen atoms. And as you may have remembered, that will be Br positive and or OH minus, that will be bonding with this. So this will attack here, and after that attack, we will have here our OH. Okay, so that's all for our electrophilic addition. So for the next parts of the discussion, these are not included in the electrophilic addition. So our next concept or next addition reaction will be oxidation. As you may have remembered, oxidation is the increase in the number of oxygen atoms in the molecule, or it can be a decrease in the number of hydrogen atoms in the molecule. So in that, one of the oxidation that uh, that can be applied or can be done on our alkene is what we call the hydroxylation. Not G, that is hydroxylation of alkenes. So by hydroxylation, we will be adding what we call hydroxyl. Alright? So in that, due to the presence of the hydroxyl, due to the addition of hydroxyl, we will actually we will actually have uh, what we call oxidation since we added a number of oxygen. So for the stereochemistry, again, this will follow what we call syn addition, meaning to say our molecules will be attached on similar side of the alkene, and just like our addition of halogens, we can actually use this oxidation or hydroxylation of alkenes for tests for presence of unsaturation. Same with our addition of bromine in carbon tetrachloride. Okay. So, in here, meron tayong isang ano lang, isang solute or isang reagent na ginagamit which is actually the cold dilute and neutral potassium permanganate. So, potassium permanganate, and KMNO4, that should be cold and dilute. And also neutral. Okay. So as you can see here, due to its neutrality, we don't actually have here a nucleophile or an electrophile. So in here, what actually happens is if we have here our double bond, uh, in addition of our cold and dilute and neutral KMNO4 or potassium permanganate, we will have here our COH. We have here OH. Syn addition, meaning same side. And so, sir, paano yan nagiging test? Kung mapapansin nyo kasi, ang naging product natin actually ay isang glycol or in ayupa, we have here a 1,2-diol or dialcohol. And as you may have remembered, most of the alcohol are actually transparent or clear. So, nagsimula ka sa clear na liquid or clear na substrate. Nag-add ka ng, tawag dito, ng KMNO4, tapos clear na liquid pa rin yung kinalabasan. So, paano yung naging test? Paano natin makikita? Actually, there is a byproduct here which is our man manganese oxide, which is actually brown in color. So, in that, makikita mo na kung ano yung nangyari. So basically, if we have here our cyclohexene again, and we added our cold and dilute and neutral potassium permanganate, cold, dilute, neutral potassium permanganate, we will have here a diol, which is actually uh, our hexane as our alcohol. So plus our MNO. So, kung gusto nyo malaman yung pangalan nito, this is actually, we can actually name this as cyclohexa 1,2-diol. Ayan. So that is for oxidation. So our next our next addition reaction is what we call the oxidative cleavage, or what we call ozonolysis. So by ozonolysis, it comes from the word ozone. So by ozone, we will actually be adding ozone. So for those of you who don't know what ozone is simply oxygen or three oxygen. So in the process of ozonolysis, we can actually have here this form we're in. If we have here our double bonds for our carbon, and we expose this to ozone, first to ozone, and next is to zinc plus acid. We will actually have here our what will happen here is, since what we have here what we call cleavage, meaning to say we'll just need to cut this or cleave this. So we'll have here oxidative, so we will just add the oxygen. What will happen here is we will have here our oxygen double bonded to our carbon, plus for the other side our oxygen double bonded to carbon, and it's two. So basically from alkene we will actually have here our aldehydes, or it can also be ketones, depending on what type of groups are attached to this. So an example here can be, or for our products here, we can have two aldehydes, we can also have two ketones, or one aldehyde and one ketone. So for example, uh, if we have here our, let's go back to 2-methyl 2-pentene. What will happen if 2-methyl 2-pentene undergoes oxidation? So what will happen here is we will have here our 2-methyl. So it means that we have here our methyl. Let's form our pentene. So we can actually have 1, 2, 3, 4, 5. So that is our pentene. We have 2-methyl. So if we started here, if this is 1, we have here 2-methyl and 2-pentene, meaning to say our double bond started at the second carbon, so second to third. So that is our 2-methyl 2-pentene. If we if this compound undergo ozonolysis, so we have here O3 and we have here our zinc and our HO3 plus. What will happen here is we just need to break this and add oxygen to it. So I'll have here this one. So that will be our 2-methyl or double bond, our oxygen, plus we have here our the rest of that, and our double bond and our oxygen. As you can see here, our product, we have here two kinds of product wherein we have here a ketone. This is a ketone because we have our carboxyl, and we have here our aldehyde because one side only have hydrogen, which is this one sa baba, and the other side have two carbon atoms. Basically, we have there our aldehyde. So, aldehyde and ketone. So that will be our addition reaction involving oxidative cleavage or ozonolysis. So I want you to try to envision or draw what will happen to this compound if this undergoes ozonolysis. Wait a second. Hmm, 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 wait lang. Better. Okay? Okay. So what will happen to this compound if we have here if we subject it to ozonolysis? So I think I will include this in a quiz wherein I would like to know the name or the structure of this compound. Basically, that will be our oxidative cleavage or ozonolysis. So for the next part, we will be having our free radical addition. So, but for now, I will be ending this video because I think the video is too long for the discussion. So I will be giving another lecture or another video next meeting. Bye.